Flatten binary tree to linked list. Let's see. Let's see. Given a root of binary tree, flatten the tree into a linked list. Okay. Okay. That's fine. A linked list should use the same tree node class where the right child pointer points to the next node in the list and the left child is always null. Okay. So basically we are given this tree with a root node and we have to convert it into a linked list where this node is same as this node, but the left is always null and right is uh, uh, works as a next pointer. The linked list should be in the same order as pre-order traversal of a tree. So pre-order means pre-order, process the node, go left, go right, process the node, go left, process the node, go left, process the node, go left, none, go right, none. Okay, come here. So we have processed the node, we have gone left, we now process the right. Okay, so makes sense. Now let's go through our template and let's find out how we can do. Input is root node. I think that's the only output is going to be again head node, basically same root. If I talk about the size, is this root going to be null? Let's see. Yeah, it can be null. So, and maximum it can be 2000. It's not BST, so we don't have to worry about the values. So values still, if we check, it's not like anything special. So there is negative, there is positive, there is 0. Duplicates are allowed. This is not a BST, this is just a binary search tree. Sorry, binary tree. Okay, fine. Coming back to our main template, that is test edge cases. So one is check for null. That's the one thing I can remember. Then I'll go design code time space. I believe the time complexity should be of n because there is nothing fancy going on here, but I will come back to it. But if I don't, then in that case I just want to have something written here. I want to work in this time complexity, but I'll confirm if I am doing it or not in some time. So let's try to design an algorithm. So let's see, I have 1, I have 2, 5, okay, 3, 4, 6. So how we can do it? One thing I can simply do is do the DFS pre-order traversal, and for each node, if it is not null, I would just create a new node, tree node, and mark it as a current, and current dot next will be this node and current will be this tree node. So that's one way. Then the space complexity becomes O of n because I'm creating different nodes, different n nodes, right? But let's see if we can use the same tree. So So let's see how we can do. Let's see, I'm here, I process this node. Okay, now I should go to left and I should go to right. So I mark it as a current node, and so this is left. So current dot next, so current dot right will be this node. So I attach it here, and so what will happen to this node? That's the question. What will happen to this node? I don't know. So let's do one thing. Let's create new nodes and just finish this question in a shorter time. What do you say? Let's do it. I think I can do that. What I'm saying is, I'm here, right? I create I have a dummy node. Dummy node next is going to be this new node with this value, and that is going to be the next current. I go to left, I create new node with this value, I attach it with this node. So current dot right is this, and I make current as this node, like this, and then I on this tree I go left, I create a new node, attach it to this. Current dot next is this. So basically you are getting the idea, right? So let's write the code for that, and let's see how it goes. So dummy node is equal to current node is equal to tree node. Okay, basically, and if not root, return root. That's a base case. We covered it. Yeah, so that's it, and let's start iterating. Let's define a DFS pre-order on the root. So I'm just gonna call it as a node, not root. And if not node, then return. Don't do anything. Otherwise, whatever the current is, so this is the current, right? So I don't have to pass it because I'm in the same this in Python at least. So current dot next is going to be a new tree node, right, with the value of node dot value, right? So current dot next, it cannot be next, so current dot right, so we have to use right pointer as our next pointer. So current, which is dummy dot right, is going to be our head node, root node, right? And then we move our current pointer. So current is equal to current dot right, and then do DFS on node dot left, do DFS on node dot right. That's basically it. So let's see how this is going to work. So I call DFS on the root node, and I return dummy dot right. So let's see what is happening. So root node is 1. I go here, the node is root, which is not null, so I go here. So our current is a dummy node somewhere around here. So current dot right is a new tree node. Create a new tree node with the value of this node 1. So I created it, and then I moved the current pointer to this location, to this location, from dummy to this, and I called dfs on node.left. So dfs on node.left. So now I come into this function again with node as 2. It will not return. What it will do is current.write. So current.write, create a new node with 2 and move the current pointer. So now the current pointer is here, and start dfs on left node. So go to left. So now 3. So we come here. So current.write, create a new node with value 3 and move the current pointer here and do the and do the dfs on left. Now when we come here, this is going to be null, so we return to this position. Nothing has happened for this. Node.write, again return, nothing has happened. So now we pop back in our call stack. Our this portion is done, so we do this portion. So this is our current pointer. So current dot write will be tree node dot value. So this will be our next node attached. So I'm not going through whole example. I think this should work. I think we are using every time we are using new tree node, so space is going to be this. Let's see if at least this works first. So current is not a local variable. Okay, I can pass it as a local variable, right? You can pass it. Okay, pass it. Something is wrong. So why it is wrong? Left and right are null, right? So why it is returning the same list? I am attaching node dot value. That's right. Makes no sense to me. Let's see. Let me remove this. Non-local current. Will this make any difference? Still not. What's the problem? What's the problem? Current is a new node, right? Current is a new node, man. Something is wrong. What is wrong? Not able to understand. It's always returning this value. Is this because of that? Oh my god. Nope. Nope. Okay, oh, okay. Okay. Okay, makes sense. Makes sense. I completely effed up. Do not return anything, modify root in place. That's the problem. That is the problem. That is why you should always understand the question. All 17 minutes wasted. What should I do? Let's try again. So this is the root, and I'm not going to return anything. So root dot right should be this value, right? Okay. What if I go in the right direction first? So I go here, this is null. So now 6 dot right is this value. I go back. Okay, how can I do it? If I directly attach it to this right, I'm missing on this tree, right? How can I do it? Another way is like saving these in a list, these pointers, and then going from here this dot right becomes the next. So to save some time, I'm just going to do something. Okay. I'm going to do something which is not ideal. So let's see. Pre-order is equal to empty list. If not node, return. Otherwise, pre-order dot append node. So I'm just going to keep an extra array of these nodes. Okay. And then I'm going to do DFS on node.left, add it, node.left, add it. If it is not, then return. Makes sense. Okay, now we have our pre-order here. Now what I need to do, let's see. To be perfectly clear, at this point, if you go in completely wrong direction, either you have failed the interview or your interviewer will point you out this thing in time so that you don't waste your time if you are thinking loud. Yeah, so that's one thing to remember. So I'm assuming I failed this interview completely, but still let's go on. It's still 20 minutes. We had 1 hour to do this, right? In actual interview. Fine. So now for node in pre-order, okay, so I just have to create a link from this node to next node. So let's do one thing. So for I in range, so always any last node is always going to be empty, right? Let's say if this is not there, then this is going to be the last node. If this is not there, then this is going to be last node, and it has null values, so I can go till this value. Yeah, I can do that. So range len of pre-order -1 and node of I dot left, node of I dot right is equal to node of I plus 1, node of I dot left is equal to null, and return sorry, this has to be pre-order, return pre-order of 0, or what does that make sense? This should at least work. Come on. Yeah, perfectly fine. I believe there has to be some efficient solution without using extra memory, and we'll check that. Let's see if this solution is accepted. Perfect. Let's see what are the different solutions. Let's see, there are, okay, he's doing DFS. This is exactly what I have. Left tail DFS of root, right tail DFS of right. If left tail can also be written as root dot left, left tail dot right, root dot right is, if right tail is not null, then it will be returned before computing entire expression. It's kind of a recursive solution without using extra memory. This guy is using extra memory. Let's see. Again. Okay, do pre-order dot arrow dot left null root dot right self dot head. So there is an extra pointer, and self dot head is root. This is quite a beautiful solution. Yeah. Anyways, thank you for watching. Have a nice day.